Hello and welcome back. In today's video, I'm overclocking the Intel Arc A380 all the way up to 2.9 GHz using Shamino's Arc OC tool and custom loop water cooling. As you can see from the video title, this is SkatterBencher number 44 and not the successor of the previous SkatterBencher video that I've uploaded to this channel, which would be, I guess, SkatterBencher 55 or 56. The reason is that I was supposed to finish this project in August last year. But back then, overclocking Arc was kind of troublesome, and I ended up releasing a video just talking about the progress I had made up until that point. I'm happy to finally put the finishing touches to this project, but spoiler alert, overclocking Arc graphics card is still kind of troublesome. So in this video, I'll try to show you how I got up to 2.9 GHz and highlight what are the current challenges that remain. Anyway, we have a lot to cover, so let's get started. The Intel Arc A380 is Intel's second slowest discrete graphics in the Intel Alchemist lineup. It was released on June 14, 2022, so last year, at an MSRP of $139 US. Alchemist is the codename for Intel's first generation desktop discrete graphics. It uses the Xe HPG variant of the Intel Xe GPU architecture. It supports ray tracing, deep learning accelerated XeSS, and DirectX 12 Ultimate. The Arc A380 is built on the TSMC N6 process and houses 8 Xe cores. It comes with a base clock of 2000 MHz and a boost clock of 2450 MHz. The 6GB GDDR6 memory is clocked at almost 1937 MHz. The graphics card TDP is 75 watt. In today's video, we will cover 3 overclocking strategies. First, we use Arc control and do basic GPU overclocking with stock cooling. Second, we use Arc control and do advanced overclocking with custom loop water cooling. Third, we maximize the GPU overclock using non-Intel software tools. However, before we jump into the overclocking, let's have a look at the hardware and the benchmarks that I'll be using in this guide. The system we're overclocking today consists of the following hardware. We use Windows 11 and the following benchmark applications to measure performance and ensure system stability. The benchmark selection is similar to the one we used in our last GPU guide. We rely on the TensorFlow DirectML plugin for AI benchmark to run our deep learning workloads. Intel did release an extension for TensorFlow, which has experimental support for the Intel Arc A series GPUs. However, it is only available for native Linux and Windows subsystem for Linux 2, not for native Windows. Before we jump into the overclocking, let's have a look at the stock performance. Here's the benchmark performance at stock. When running FurMark GPU stress test, the average GPU clock is 2447 MHz with 1.026 volts, and the GPU memory clock is 1937 MHz. The average GPU global temperature is 59 degrees Celsius. The average GPU power is 62.579 watts. For future reference, I also extracted the default voltage frequency curve from the A380 GPU. As you can see from the chart, the GPU works from 100 MHz at 0.66 volt up to 2450 MHz at 1.035 volts. In our first overclocking strategy, we take advantage of the overclocker's toolkit that's included in the Arc control software. The Arc control software is arguably one of the more controversial points of the Intel Arc launch. At the very beginning, a lot of people were complaining about the usability and the bugs, but Intel has made a lot of progress in improving the Arc control software and even released a standalone desktop version just a couple of weeks ago to improve the user experience. Since the beginning, Arc control has provided enthusiasts with the tools to overclock their Arc GPU. Today, the tool still provides the same overclocking knobs as at launch. The knobs include the GPU performance boost, GPU voltage offset, GPU power limit, and GPU temperature limit. While it's evident that these tools should give us some control over the factory-fused voltage frequency curve, unfortunately it's not entirely clear what each of these options do exactly. So let's have a closer look. GPU performance boost offsets each point on the voltage frequency curve with a specific frequency. The slider goes from 0 to 100, with 100 presumably reflecting 100% of the maximum allowed offset frequency. At 100%, the GPU frequency is 2750 MHz, which is a 300 MHz increase over the default maximum frequency of 2450 MHz. GPU voltage offset enables the restricted parts of the factory-fused voltage frequency curve. In this case, the slider ranges from 0 to 258. That presumably indicates the maximum voltage offset allowed for this GPU. We'll get back to that later in the video. Note that this isn't an actual voltage offset, but enables higher VF points. When the GPU boosts to a previously restricted voltage frequency point, it will boost to that frequency and voltage. In my first video about overclocking an Intel Arc graphics card, I made the observation that it feels very similar to NVIDIA GPU overclocking. And with what we learned from these two overclocking sliders, that observation still stands. When fine-tuning, we use both sliders to enable a higher voltage range and add extra frequency for each VF point. However, I will only use the performance boost slider in this OC strategy. GPU power limit allows configuration of the allowed GPU power consumption. The power, in this case, is the estimated GPU power and not the total board power. GPU temperature limit enables boosting with higher temperatures. But with this GPU, we never come close to the stock maximum limit of 90 degrees Celsius. I have a couple of additional notes on the overclocker's toolkit. First, a prominent item missing from the overclocking toolkit is one to overclock the graphics card memory. It seems that Intel has, by design, chosen not to support memory overclocking on their first generation Arc discrete graphics cards. 2. The slider limits in the current drivers are much lower than those in the launch drivers. The changes coincide with the release of the 3276 beta driver from August 29, 2022, which ironically was the driver I was told would fix the PL4 throttling issues I discussed in my previous Arc A380 update video. I published that video on August 22. For this OC strategy, I set a GPU performance boost of plus 50, which results in an increase of 150 MHz up to 2.6 GHz. I also set a power limit of 78 watts and a maximum GPU temperature of 95 degrees Celsius. Upon opening the Intel Arc Control software, go to the Performance tab. Under Performance Tuning, click Configure. Set GPU Performance Boost to 50. Set GPU Power Limit to 78 watts. Set GPU Temperature Limit to 95 degrees Celsius. Then click Apply to confirm the settings. We reran the benchmarks and checked the performance increase compared to the default operation. The performance improvement after increasing the GPU clock frequency by about 6% is slightly all over the place. We see a linear performance scaling in specific benchmarks, whereas in other benchmarks we only see minor performance improvements. When running Firmark GPU stress test, the average GPU clock is 2600 MHz with 1.035 volts, and the GPU memory clock is 1937 MHz. The average GPU global temperature is 61.2 degrees Celsius, and the average GPU power is 65.286 watts. In our second overclocking strategy, we change from stock cooling to custom loop water cooling. In addition, we expand our overclocking approach with also some voltage tuning with that GPU voltage offset slider. While I'm familiar with Bixby as a company, I never really tried one of their GPU water blocks, but turns out that they actually made a water block for this Gunnir A380 graphics card that I bought. So I decided to purchase one. Why? Well, one, because I guess science and because it would be fun, but two, also for the VRM cooling. While the stock Gunnir cooling is more than sufficient to handle the low-end GPU at full load, the same cannot be said about the VRM. The stock thermal solution does not cover the GPU VRM components and has nearly no airflow reaching them. While that certainly suffices for stock operation, as we've seen with other low-end GPUs like the GT1030 and RX 6500 XT, The VRAM temperature under load is often the critical bottleneck when overclocking. The same applies to this A380. With the full cover water block, the VRAM components are now actively cooled, and there should no longer be any concern for the operating temperature when overclocking. As I already mentioned, the GPU voltage offset slider enables us to extend the available voltage frequency curve. While the slider goes up to 258, beyond 120, the voltage stays at 1.16 volt with a maximum boost frequency of 2700 MHz. By combining the GPU voltage offset with a GPU performance boost of plus 50, we get the GPU frequency up to 2782 MHz, which is about a 340 MHz increase from stock. Upon opening the Intel Arc control software, go to the Performance tab. Under Performance Tuning, click Configure. Set GPU Performance Boost to 50. Set GPU Voltage Offset to 140. Set GPU Power Limit to 78 watts. Set GPU Temperature Limit to 95 degrees Celsius. Then click Apply to confirm the settings. We reran the benchmarks and check the performance increase compared to the default operation. Similar to the previous overclocking strategy, the performance improvement after overclocking the GPU by almost 14% is still all over the place. However, we are starting to see performance uplift in most benchmarks. When running Firmark GPU stress test, the average GPU clock is 2782 MHz with 1.153 volts, and the GPU memory clock is 1937 MHz. The average GPU global temperature is 53.1 degrees Celsius. The average GPU power is 77.896 watts. In our third overclocking strategy, we switch from Intel's toolkit to using non-Intel software tools for overclocking our A380 graphics card. In the summer of 2022, when Intel had just launched their Arc discrete graphics cards, there weren't really that many tools available to also overclock them. With the help of Shamino, we built a very simple user interface that exposes the entire overclocker toolkit integrated in the Intel Graphics Control Library, or IGCL. That's publicly available. I also recently shared this tool on my blog. This tool was essential to achieve the first 3 GHz overclock of an Intel Arc graphics card. Next to the 4 overclocking knobs also available in the Intel Arc Control software, it has a couple of additional benefits. The main benefit is that it exposes the OC lock feature for overclocking. With OC lock, you can specify the voltage and frequency of the specific active voltage frequency point instead of the OC offset, where you still rely on a dynamic frequency. Another benefit is that it gives us much information about the OC capabilities of the graphics card. For example, we find that the maximum supported GPU frequency offset is 300 MHz, so from 2450 MHz to 2750 MHz for the A380, and that VRAM frequency and voltage offsets are not supported. My blog also explains how the OC lock function works. While I'm still using the tool in the same way, it seems it functions a little bit differently with the newer drivers. I will update my blog to reflect this change. The OC lock function works as follows. Use OC lock frequency to set the desired GPU frequency for the active VF point, and use OC lock voltage to set the desired GPU voltage for the active VF point. This is the most effective way of increasing the frequency, though it is still subject to the GPU PCU algorithms. The OC lock frequency setting works as expected, so setting a specific target frequency will result in that frequency. The OC lock voltage doesn't work as expected, as the set voltage is offset by about 185 mV. So if you set 1 volt in the software, the actual voltage would be around 1.185 volt. So that's it, right? I have a software with the right overclocking toolkit, so I can overclock my card to the moon, right? Not so fast. There are still a couple of elements that are holding back our Arc overclock. Power limits, PL4 throttling, and voltage limits. Let's have a closer look at each of these elements. Since the Arc OC tool by Shamino relies on the Intel Graphics Control Library, it's unable to bypass the power limits imposed by the library. In my previous Arc A380 overclocking video, I hinted that there are some proprietary tools that are able to override those PL1 and PL2 power limits, but unfortunately I'm unable to share those tools in public. In the meantime, however, enthusiasts have worked on finding workarounds for these power limits, and actually there are some. One method is to mess with the Arc control service as described in a Tech PowerUp forum post. However, the most convenient method I found was shared to me by an Elmo Labs Discord user named Dino. To make a long story short, the Acer Predator Bifrost overclocking software allows users to create a user profile and manually adjust the power limit to any value. The process is as follows. First, of course, download and install the Acer Predator Bifrost software. Then, when installed, open the software and create a new profile, then close the software. Now browse to App Data Roaming Predator Bifrost and open the settings file. Now look for your custom profile and change the power limit value to anything you want. Make sure to save the file. Then open the Acer Predator Bifrost software again and activate your custom profile. You can verify with hardware info that the power limits were set correctly. I use this process to create my own custom profile with a power limit of 400 watt, which I will be using in this OC strategy. So that's it, right? We have unlocked the power limits, so now we can overclock it to the moon. Not quite. In my 3.1 GHz Arc A380 update video, I hinted that there were some PL4 throttling issues, and I also described some ways that we could maybe work around those issues. I would refer you to that video for the full explanation, but here I'll try to keep it short. Basically, it boils down to this. Beyond a voltage of 1.17 volt, the GPU will forcibly decrease its frequency. To illustrate this issue, I tracked the actual GPU frequency during a GPU-Z and FurMark workload with an increasing operating voltage and a fixed set frequency of 2800 MHz. I also set the power limit to 400 watt and track the GPU power to exclude this from a possible cause of throttling. As you can see, until 1.17 volt, the actual GPU frequency equals the set frequency, 2800 MHz. However, beyond 1.17 volt, for every 10 millivolt increase, there's an approximate 50 MHz decrease. The decrease in frequency in GPU-Z and FurMark is the same, indicating it's not related to power or current limiters. I refer to this problem as a PL4 throttler problem because our only indicator is the PL4 throttling flag lighting up hardware info. However, I must emphasize that I don't know the root cause of this throttling behavior, so it may not be PL4 specifically that's the issue. Regardless of the root cause of this issue, whether it's really PL4 or just another issue that then ends up lighting up that PL4 throttling flag, the practical implication is that we can't push the GPU to the limit. In my previous video, I already discussed a couple of ways that we could think about working around this PL4 throttling issue, but so far none of it seems to work. So we're just going to have to deal with this issue for the time being. However, even if we would be able to crack the PL4 throttling issue, there's another bottleneck that will prevent us from pushing the GPU to its limit. There's a voltage limit. Any voltage that I set using the OC lock feature above 1.2 volt or 1.275 actual voltage doesn't result in anything. So we're limited to 1.275 volt. Now, the voltage limit is in part a good thing. As I highlighted in my other A380 video, with the launch drivers, it was actually possible to set a GPU voltage of over 2 volt, which isn't very safe. So I'm glad it got fixed. Open the Acer Predator Bifrost software. Go to the User Mode tab. Select your custom created profile. Close the Acer Predator Bifrost software. Open the Shamino Work Tool software. Under the Intel tab, click on Arc OC. Set OC lock frequency to 2900. Set OC lock voltage to 0.96. Set OC temp limit to 95. Then click Apply to confirm the settings. We rerun the benchmarks and check the performance increase compared to the default operation. With the GPU frequency further increased, we also see a further improvement in the benchmark performance. We get a maximum performance improvement of plus 19.82% in Geekbench Vulkan. When running Furmark GPU stress test, the average GPU clock is 2902 MHz with 1.155 volts, and the GPU memory clock is 1937 MHz. The average GPU global temperature is 53.3 degrees Celsius, and the average GPU power is 79.743 watts. Alright, let's wrap this up. To be honest, I'm almost relieved to finally put the finishing touches on this project. This SkatterBencher guide has been lying on my desk since the summer of 2022, and I generally don't like to leave business unfinished. But that's not to say that this is completely finished business. To be honest, I kind of hope that someday we will get the tools and the workarounds needed to push Intel Alchemist to the absolute limit. Today, even with regular water cooling, we're not even near the limit. Instead of commenting on the performance gains from overclocking the Arc A380, I would like to take this opportunity to talk a little bit about supporting overclocking enablement. Of course, I'm biased. Overclocking is my hobby, and of course, I want to have the most amount of tools available to enjoy my hobby. But I think in addition to the support for the overclocking hobby, there's two key arguments in favor of better overclocking support and investing in overclocking enablement. The main argument is that customer preference has shifted towards hyper-customization in today's PC DIY market. That ranges from the broad aspect of choosing your own components and giving your PC a unique aesthetic with custom loop water cooling, to the absolute minute details of choosing your custom keyboard keycaps and custom RGB lighting patterns. Overclocking or undervolting falls within the spectrum of hyper-customization, as it's nothing more than customizing your silicon to operate precisely to your needs, whether that's at the highest frequency or at the lowest power consumption. The second argument is that overclocking is a matter of device ownership, just like the right to repair. If we forgo our warranty, we should be allowed to do anything we want with the hardware we buy. In a sense, supporting overclocking enablement is similar to supporting the right to repair. It means supporting giving customers the ability to modify and repair their devices as they see fit. Anyway, that's it for this video. I thank you for watching and the patrons for the support. As per usual, I will have a written version of this guide up on my blog if you want to read through the BIOS settings or have a look at the performance results. If you have any questions or comments, feel free to drop them in the comment section below, and see you next time.